This is the spiritual home of British astronomy, the Royal Observatory Greenwich. And we're here for the final programme of 2019 to look back at what's been a remarkable year.
We've explored the most distant object yet, had new results from the surface of Mars, and seen the first image of a black hole.
Tonight, we'll be reliving the high points of those stories.
We have seen what we thought was unseeable, a black hole.
Finding out what's happened to them since. This is one of our first Mars quakes. This is really incredibly exciting.
I have to pinch myself a lot of the time because it does just feel so surreal.
And we'll be looking forward to see what the future holds.
It is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years.
Welcome
To the sky at night. For space enthusiasts, 2019 started with a bang. On December the 31st, we were in Baltimore, not to welcome the new year, but to observe a much more exciting event. The New Horizons spacecraft was due to fly past an object in the Kuiper Belt, the ring of icy debris that surrounds the solar system. It was the most distant flyby ever attempted. We're a matter of hours away from the flyby, and here at Mission Control, you can feel the excitement and the tension rising. New Horizons is on its way to an encounter with a small icy rock known to the catalogue as 2014 MU69, but to the team, it's Ultima Thule, an ancient name for a place beyond the edge of the known world. It's further away, and it's fainter than Pluto. And so this is truly a voyage into the unknown.
We have a pretty good idea of its size. It's about 20 miles across.
This is a lot harder exploration, much tougher flyby than the flyby of Pluto.
We really don't know very much, and that, of course, is part of what's so exciting.
6, 5, 4, 3, 2, 1.
At precisely 33 minutes past midnight, the team celebrated as 4 billion miles away, the New Horizons spacecraft sped past its target. We'd never seen an object like this close up before. Since the flyby, scientists have been analysing the data returned by New Horizons to try to understand the origins of this mysterious object, which is now officially named Arrokoth. As I discussed with planetary scientist Meg Schwab. What have we learnt since the flyby?
So this is the image that came down from New Horizons in January. I almost think that this object is even more interesting than Pluto because this is the first time we're really getting to see something that was formed out there undisturbed. And we think that this might be a contact binary, that these were two pieces separate that were orbiting each other and then slowly merged, sort of forming that brighter neck there.
And so the important thing there is the slowly bit, that this was a slow process, not a violent collision that brought these two bodies together.
Exactly, because knowing how these objects orbit, if it was a more violent collision, the orbital speeds are such that these two objects would have obliterated each other.
So that's the first discovery, that this can build up material slowly. Now, what about the colour? We were speculating a lot about the colour, and here's the colour image we got from the flyby.
So we're seeing a very reddish surface, which is typical for objects in the outer solar system. And we see a lot of it on Pluto, and particularly this red is coming from organic gunk. So it's sometimes dubbed tholins. It's sort of taking methane and other ices. As it gets irradiated by the sun, you get redder and redder surfaces.
I remember standing in Maryland talking about this as a snowman, as two spheres put together. That turned out to be wrong.
No, it's no longer a snowman. It's more like a gingerbread man, I guess. We thought maybe it was going to be a full sphere, but as the spacecraft flew by, it turned around and looked back at the object. And so what you got to see was sort of the crescent bit of the object sort of with the sunlight reflecting off, and that gave you a width measurement. And so they were able to show that this wasn't round, that it was just a tiny sliver, showing that it was really this very flattened shape of two objects sort of stuck together.
How do you get something that's this shape?
I think it's still an open question, but we also know that we see similar things in other parts of the solar system. Pan and Atlas and Pandora are tiny satellites of Saturn, and they're very much shaped like this. And so it's probably telling us something about formation, and that if it happens there, maybe it's not so surprising we see in other parts of the solar system.
As New Horizons was pushing back the final frontier in the outer solar system, another mission was being deployed closer to home. NASA's InSight spacecraft had parachuted onto the surface of Mars towards the end of 2018. Over several weeks, it deployed its instruments, designed to listen for tremors or Marsquakes emanating from inside the red planet. The hope was that if Marsquakes could be detected, they could be used to study the internal structure of the red planet. The only problem was, no one knew if Mars was still geologically active or whether Marsquakes existed. When we last visited the team, they were receiving data from InSight, but had yet to detect any signs of the elusive Marsquakes. So I caught up with Anna Holliston to see if they'd found any signs of activity on Mars. So Anna, it's been over 6 months since you were last on the programme, and last time you were looking for Marsquakes. What have you picked up so far?
We found one on what we call Sol 128, which was April the 7th. Now we've actually seen something in the order of a couple of hundred quakes since then, or signals that could well be quakes. If we listen to this now, we're going to hear some wind first. You hear that?
I can, like a sort of low...
Yeah, that's wind. The next thing is going to be the first Marsquake.
Oh, wow. That's not what I was expecting.
It's a very different sound.
Yeah. Now, I think many people thought that Mars was inactive and sort of nothing going on, but yet we're seeing all these quakes. Is this a surprise?
Yes and no. We know it had a hugely active geological past. You know, we've got Olympus Mons. 3 times the height of Everest? It's huge, this volcano. So that is there, and it's not the only one. We've got the Valles Marineris, which is this huge canyon, again, which would dwarf the Grand Canyon. These are huge geological structures. So obviously it had a very active history, geologically speaking. But now it obviously, it's lost a lot of that heat and has cooled, but that planet must still be a little bit warm inside. And although we don't have plate tectonics like we do here on Earth, obviously there's still settling, cooling, contracting going on.
So it continues to lose that heat,
yes.
And that seems to manifest itself as seismology.
Yeah.
So this is really incredibly exciting.
Yeah, this is, overwhelmingly exciting. We'd really hoped we'd see them. No one had ever recorded something actually, from the ground. So to be there and have a seismometer and to pick up those vibrations from something inside the planet, making it shake, I have to pinch myself a lot of the time, because it does just feel so surreal that we're recording it and it's really happening.
Thank you.
This year, we've also seen the announcement of new missions which will explore the solar system. In August, we featured the competition to choose the European Space Agency's next mission. The competition, which was won by a revolutionary project called Comet Interceptor. The plan is to launch a spacecraft that will wait 1 million miles from the Earth until a suitable comet is detected entering the solar system. At that point, the spacecraft will break in two and intercept the path of the comet to study it at close range. To find out why they want to do that, we sent Lucy Green to meet Comet Interceptor's principal investigator, Geraint Jones.
We visited comets before, so why is it so important that we visit another one? So from previous comet missions, we've learnt a huge amount. So Giotto to Halley, Rosetta to 𝐘𝐞𝐚𝐫. So there have been big advances in our understanding, but the comets that have been visited by spacecraft up to now have all been past the sun many times. Each time they pass close to the sun, the ices on the surface get heated, they change, and they also get covered in this layer of dust that falls back down onto the nucleus. So we like to see a pristine one coming in from the outer solar system for the very first time. If we can visit one of those objects, we'll truly see what the original material was like when the planets were being formed.
Since winning the competition, the technical scoping for the project has got underway. Just last week, ESA released these first preliminary designs of the spacecraft. And we look forward to updating you on progress all the way up to the launch date in 2028.
Across the Atlantic, NASA has also been announcing new missions. In 2026, it plans to launch a revolutionary spacecraft to Saturn's moon Titan, called Dragonfly. Rather than landing a rover on the surface, Dragonfly will be able to fly through Titan's methane-rich atmosphere, allowing it to explore much more of Titan than would be possible with a conventional lander.
Also this year, we celebrated the 50th anniversary of the Apollo 11 moon landing. To commemorate the event, the US government announced plans to return people to the lunar surface.
It is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years.
To most observers, 5 years is an ambitious, almost impossible timescale. It was the question I put to NASA Chief Scientist Jim Green when I met him in Manchester. I can't think of a mission that was developed in 5 years from scratch to
Sure,
launch.
sure.
You know, Mars 2020 has taken a decade, and because these things are complicated.
Sure.
Are we really going to get there?
Well, it's not from scratch. We've been working on it for years, okay? We're nearly done with the development of the rocket called the Space Launch System, SLS, that will take us there. Our first test flights are going to be in 2020, next year. And then we will do several before we then land humans on the surface. You know, we're really almost probably 85% there.
What's the most difficult thing that's remaining? What's the biggest jump?
Okay, to me, it's really all about the landing system with humans. It's all about that end phase, right, where we actually get down to the surface.
Crack that, and then you can go in.
But we got good time to do it.
Since then, NASA has continued to press for that ambitious 2024 deadline. In November, it announced that it was working with 5 private companies who were all developing lunar landing craft. The first of which hope to touch down on the moon's surface as soon as next year.
A review of the year isn't just about the missions we send out into space, but also about what we can see from here on Earth. So Pete's been looking back at what's been an eventful year for stargazers.
It's not always easy being a stargazer in the UK. In fact, the last few months have been particularly challenging. With a record-breaking wet autumn, we've barely seen the night sky at all. But when the clouds have cleared, the sights which have been visible have been truly spectacular. I've been looking back at some of the highlights of the year as submitted to the Sky at Night online photo group. Astronomy in the UK got off to a flying start in 2019 because we had a total eclipse of the moon in the early hours of January the 21st. And that's beautifully shown here in this photographic montage taken by Alberto Palladino. And it shows the event from start to finish, including the beautiful red-coloured totality that you get during a lunar eclipse. Now that red colour comes about because during totality, the moon moves into the central dark umbral part of the Earth's shadow in space. Now that shadow isn't completely dark. The Earth's atmosphere refracts sunlight, so it infills the shadow slightly. But because the Earth's atmosphere is also very good at scattering blue light, it's mainly the red part of the spectrum which gets through, which is why you get these beautiful red colours.
In the UK, we were limited to lunar eclipses, but we get submissions to the photo group from all over the world. And in July, we received many extraordinary images of a total eclipse of the sun, which was visible over South America.
And this one in particular caught my eye. It was taken over the La Silla Observatory in Chile. And you can see the beautifully eclipsed sun there, the dark disk of the moon surrounded by the sun's corona. But what really stands out is this dark shape here, and that's the shadow of the moon passing through the Earth's atmosphere. It's a really beautiful photograph.
While Chile was basking in its eclipse of the sun, there were still spectacular things to see in the northern hemisphere.
Now, the summer is the best time to see the brightest parts of the Milky Way. During the winter months, we are looking out in the opposite direction to the Milky Way's bright core. So we're looking through a thinner layer of stars and the Milky Way appears less dramatic. But unfortunately, from the UK, it never gets fully up. But it's still a dramatic sight nevertheless.
This magnificent view over the coast of Pembrokeshire has caught not just the Milky Way, but a meteor, part of the Eta Aquarid shower in May.
There are many meteor showers which are visible from the UK throughout the year. Some of them are pretty spectacular. And what really stands out here are the colours. Now, the colours occur because the particle which comes through the atmosphere and vaporizes has its atoms mix with the atoms in the atmosphere. So they interact together, and as they get excited, they give off light. And here you can see a beautiful green colour transitioning into a very dramatic pink. And that will reveal the makeup of the meteor as it's coming through the atmosphere.
And finally, the planets of the solar system have also put in dramatic appearances this year. In January, we were treated to Jupiter and Venus flanking the early morning crescent moon. And then Saturn appeared in our skies.
In this photograph, we've got Saturn photobombing the moon, or rather I should say it's the moon photobombing Saturn, because from certain places on the Earth it was possible to see the moon move in front of the planet Saturn, and that's an event known as an occultation. But the solar system's smallest planet also got in on the act. During November, the planet Mercury appeared to move in front of the sun's disk. And that's an event known as a transit of Mercury. And when you see a photograph of that tiny dot of Mercury against the sun, it really hammers home how small Mercury is and how immense the sun is as well.
That's it for this year. If you want to see more of the pictures submitted to the gallery, or to submit your own, you'll find the link on our webpage.
But for all the brilliant photos submitted by our viewers, the most revolutionary image of the year was unveiled at a press conference in Washington, D.C. by Shep Dollerman, director of the Event Horizon Telescope.
We are delighted to be able to report to you today that we have seen what we thought was unseeable. We have seen and taken a picture of a black hole. Here it is.
Well, here it is. Here's the image. It's really, really quite something to see this. You've got the shadow of the black hole itself here. They've just said that the light drops off really steeply, just like you'd expect for a proper black hole. You can see the bright material, that's light that's just escaped falling in, and it's brighter down here than on the top. And we think that's because the black hole's rotating. But there's so much more to learn from this image alone. It's going to be really exciting to work out how this black hole behaves. Capturing this image was a massive achievement. a collaboration between radio dishes all over the world that linked together to create a telescope the size of the Earth. It was only when all those dishes lined up simultaneously on the centre of M87, a galaxy over 50 million light-years away, that they were able to generate the resolving power needed to image the black hole that lies at its centre. But this was not the only supermassive black hole to make the headlines this year, as Maggie discovered when she met astrophysicist Rob Fender.
So, Rob, this has been a good year for imaging supermassive black holes, and I guess nothing sums it up quite as well as this image here. But I was told that initially we weren't too sure which supermassive black hole they were going to image.
Yes, that's true. So there are two black holes which have about the same angular size on the sky. So this one is M87, which was this amazing image which was released this year. But also, in fact, the black hole at the centre of our own galaxy, which is called Sagittarius A star, has about the same angular size on the sky. And I think for a lot of people, they were expecting that when the first press release came out, that it would be Sagittarius A star which was released.
So why was the decision made to release this one?
M87 is much more stable. So they actually averaged data that were taken over several days with the Event Horizon Telescope. M87 essentially didn't vary at all on that timescale. However, Sagittarius A star, the black hole at the centre of our own galaxy, actually varies on timescales of tens of minutes or so. So if we look here at this sequence of images, this is a sequence of infrared images from the Keck telescope. It's actually varying. There it goes. It's varying very, very rapidly.
It is. So it's like taking a photograph of sort of an action shot. If there's lots of movement, then that blurs the image.
Exactly.
And so for the first image to be publicised, I guess they wanted something nice and crisp.
Exactly.
So what's causing that variation?
So what happens, the reason that we see these black holes varying is because actually the rate of matter that's falling down onto the black holes is varying. So this is not an isolated black hole sitting there in space on its own, but in fact matter is falling down towards it, and as that matter falls down, it becomes hot, it glows, and we see it. And what we see in these kind of images is that it's flickering very rapidly as this matter's falling down.
Yeah, because if we look at it here, it's sort of getting dimmer and dimmer, almost disappears.
Yes.
And then sort of in a second, sort of whap, it gets a lot brighter.
Yeah, exactly. So the rate of material falling down onto Sagittarius A star at that point dramatically increased, and we saw the brightening. We saw the release of the gravitational energy as the matter fell very close to the black hole. Yes.
And so if we were to look back in time, is there any evidence that this process has been going on for a while?
There is indeed. So it's been a fantastic year for images of black holes, I have to say. So this is the region around Sagittarius A star in the radio band.
This is actually real data, because it looks like a piece of art.
Yes. So these are real data which were taken with the new Meerkat radio telescope, which was just inaugurated last year. So this image is on a much larger scale than the one you were just looking at. This is several degrees around the centre of our galaxy. And around here is the black hole at the centre of our galaxy, which we were just looking at.
So Sagittarius A star.
Sagittarius A star. And you see all sorts of interesting structures in this image. So you see lots of these little circular things here, which are actually remnants of supernova explosions which happened in the past.
Yeah, they look like bubbles.
Yes, exactly. So it's just essentially a star has exploded and blown a bubble in the interstellar medium. And there's lots of other interesting structures that actually, frankly, we don't really understand. But the thing which was new that's revealed very clearly in these images are these structures here on several degree scales that are extending below to the south and to the north of the black hole around our galaxy. So it's very good evidence that actually, on average, over the last 100,000 to million years, our black hole has been active.
We're a long way away from the centre of our galaxy, but should we be worried at all?
No, we shouldn't be worried. We're going to be perfectly safe from this kind of activity. So these bubbles have taken about 100,000 years to propagate over distances which are much smaller than the distance of us to the galactic centre. So we're fine for now.
Yes. Well, they are some amazing images, and as you say, it's been a fantastic year for supermassive black holes.
It has. It's been stunning.
Fantastic. Thank you.
Cheers.
We finished this year with a Christmas treat. An update on Juno, one of the most impressive spacecraft we've ever sent into the solar system. It's been orbiting Jupiter for 3 years now and sending back remarkable images. And as I discussed with planetary scientist Katrina Jackman, these breathtaking images are transforming our understanding of the planet. So these images from Juno are just spectacular. They're so much better than anything we've had before. How does Juno manage to take images that are so good?
Juno is a record-breaking mission. It's the fastest ever human-made object, and it's on a really daredevil orbit near Jupiter. It travels really, really close to the cloud tops within about 3,000 kilometers, and it also takes it up over the polar regions, which allows it to look down on the northern and southern poles and image the aurora in great detail.
Well, the results are amazing. This is just an example of the kind of image. What exactly are we seeing here?
Well, it's almost art. It's where art meets science. So we're seeing structure in Jupiter's atmosphere. We're seeing storms like cyclones. We're seeing the bands, and we're seeing these swirling cloud tops, which we know are far from flat. We know that there's actually vertical structure in here that's up to 3,000 kilometers deep into the planet. And so huge pressures at the bottom of those clouds.
And it's a reminder that we're just looking at an atmosphere here, but it's complex and it's changing as well.
It's very complex, and there's still so much that we have yet to understand about the colors that form these bands and these belts and zones, and so much to understand about how these storms can be so long-lived.
Well, the best example of that, of course, is the Great Red Spot, the most famous feature on Jupiter, and here's Juno's view of it.
So the Great Red Spot has been raging on Jupiter for more than 300 years. It's about 1.5 Earths wide.
Wow, so this is a storm that you could fit the Earth inside.
Absolutely, it's really huge. And that raises an important question for Jupiter is, how can storms be so big, and also how can they be so long-lived? Because if we think about storms on the Earth, lots of them dissipate when they meet a landmass. But of course, Jupiter is a gas giant planet, and so there's no land mass to dissipate these storms, so they can last for hundreds of years. But we can now see it changing before our very eyes. So Juno has been there since 2016, and we have images over the years that are very, very close up to this Great Red Spot, and we can see that its edges are changing. And if you squint your eyes, you can also see that it's also changing in color. And so we're looking to understand what is going on at Jupiter in terms of its local weather to change this Great Red Spot. And that's the beauty of an orbital mission, because you have time to study how things change over the seasons. You have time to observe weather patterns changing before your very eyes.
Now, one of the things we'd love to know is, whenever we see these images, we're just looking at the atmosphere, we're looking at the clouds, as you say. What's in the middle?
We don't know is the short answer. So again, if you look at textbooks of Jupiter, some present different theories about what's inside the core. Some suggest a solid core. Some suggest that there's liquid metallic hydrogen inside the planet. And really, we don't know that. And in order to find out, we need to make many, many close passes. We need to take some very high resolution gravity measurements to understand what's underneath that atmosphere.
When Juno's doing that, it's kind of interesting to know what's at the core of Jupiter, but why is that important?
Because Jupiter is the biggest planet in the solar system, we think that it formed first, and we want to understand where exactly it formed, how all of the other bodies in the solar system formed relative to it. And if we can understand Jupiter, that helps to unlock a lot of the secrets of the other bodies in the solar system.
Well, it's exciting stuff. Thank you for our update from Jupiter. We'll talk to you again towards the end of the mission. Thanks.
Pleasure.
That's all we've got time for this month and this year. But if you do want to go stargazing over Christmas, Pete's Guide is on our website.
And if you're lucky enough to get a telescope from Santa, do tune in to our January episode, where we'll be telling you all you need to know to become an avid astronomer.
Good night.
Wild Wonders on Earth, David Attenborough's 7 Worlds, 1 Planet is streaming now on iPlayer. And you can listen to the soundtrack of the stunning series by downloading the BBC Sounds app for the 7 Worlds, 1 Planet music mix.